On page 5 here, where we have problems 20 through 22. First one here is asking for a slightly different lactam here, the gamma lactam, and the lactam here is a little bit better. The am here stands for amide. It's a cyclic amide. B is the answer on that. I won't dwell too much on that. 21 now is a really good problem. I'm going to draw that one out on a white sheet of paper here. So here we have a long list of reagents, and with these here there's no retrosynthesis, there's no product to look at, we just have to go in the forward direction. For whatever reason I made a skeletal structure, or I made a condensed structure out of this one, and I'm going to convert that to a skeletal structure. So in the first reaction here we have acid that's added with plenty of water. Right here there's a number of different ways that can come up. We could say we added hydronium, or we can just add H plus there in that case. You never know how that's going to come up. A lot of times on most of my tests I have the actual reagent shown here, but the ACS may refer to one of these two here. And so this one here is a Markovnikov's addition. Let me remind you, Markovnikov's addition is where we add a hydrogen here and we form the most stable carbocation. Then the nucleophile will add to the most substituted side. That's Markovnikov's rule. In this case it didn't matter because there was not a least or most substituted side. They were equally substituted. Okay, and then we get this positively charged oxygen over here, and the last step is in the mechanism. The sulfate is going to come along and deprotonate that to become an alcohol. So that was mostly just a review there for you to remind you of Markovnikov's rule. But let's move on. Moving right along right here, we have chromium. Chromium adds with some more acid oxygens. In this case we're not adding anything because we're not at a terminal carbon. We don't have a primary carbon, we have a secondary carbon. That carbon right there is attached to a carbon here, and it's attached here on the other side. So instead of adding extra carbons, what we have here is we're adding an extra bond to the already existing oxygen. Again, chromium oxidizes. Okay, and now we have an electrophile set up to carry out a reaction here with cyanide. Now the potassium is shown. Again, ignore these potassiums, lithiums. They usually have zero input here in the reaction. Cyanide is going to attack the carbonyl, and we're going to pick up a proton from the acid here, any kind of acid that's present, HCN or HCl, whichever one. We'll pick up that. This is kind of an incomplete mechanism here, not extremely important for understanding the problem. But we get this cyanohydrin right here. This cyanohydrin is going to be, here's the key one for this particular chapter. This actually came up in the last chapter 21. The cyano group can be hydrolyzed with acid or base. Usually when it's a cyanohydrin, it's an acid with a little bit of heat right there. So we add that acid, plenty of water, and some heat right here. Acid, plenty of water, and heat, and that is going to oxidize this, add oxygens to that carbon right there. So the CN becomes a COOH on that one. Now I just have to look at my answer choices, and B is the answer on that. turned a little bit upside down. Okay, number 22 here, NMR problem. This will definitely be on the test tomorrow. With 22 here, we have the same molecule, and I'm just asking for the peak assignment on this. Now you may see this one, or you may see one where we have different isomers, different constitutional isomers of the same type of compound. Okay, so let's look at this, and you should be going through on problem number 27 there. I actually went through, excuse me, not 27, wrong one. It was problem number 33 online there. I went through the method of memorization. Go through and draw up your NMR table for the chemical shifts. This one here, this is benzene. Right here, this one is usually something attached to an oxygen right here. With that one, this one may also be attached also to an oxygen because it's also close to a 4. And this one over here is the farthest away from any kind of electronegative groups because it is the least de-shielded right there. So again, over here on this side of the spectrum, this is de-shielded. And just the opposite over here, shielded in this direction here. And that refers to the electrons surrounding the nucleus. Okay, so A and B should be the benzene here. Let's look through the list. Oh, we can see we can eliminate that one right there because D and C are not going to be that far. Or excuse me, the benzene's not going to be this far upfield. Okay, so but it's down to 3 answer choices. Let's look at this one right here, the next one, because A and B are the same on the other 3. This one is a quartet. If you can see that, oh, it's blown up right here. It's a quartet, meaning we have 4 peaks. And the n+1 rule then for this one would be 3 + 1. That means that is a methyl group. Okay, and that's the neighbor for it. Let's look at C, the way these are labeled here. C is by a methyl group here, C is by a methyl group here, so these are possibilities. C on this one, on the other hand, is by nothing. So it can't be that one because that one would appear as a singlet. That is not the case. That one would have no splitting. Okay, so it's down to these 2. Let's go to the next peak here, the D. D is saying it's a singlet right here. And you look at this D, that's not going to be a singlet. Let me draw them in. There's 2 hydrogens here. So the signal for D would be 2 + 1 = 3. Math that I can do. That is a triplet. So, and that's not a triplet, so this cannot be the answer. C is the answer because that is the other thing attached to another oxygen over here. That would be a singlet because it's not within 3 bond distances from another set of hydrogens. Okay, and that's the answer for that page.